So these notes are going to be a little bit messy, but I know some of you are struggling and could really use an overview. So it's better than nothing, right? So we've been talking about bonding. Specifically, we've been focusing on ionic bonding, which if you look down here at our types of bonding, we're talking about ionic in this unit. An ionic occurs between a metal, which has a positive charge, so it's a cation, and a nonmetal, which has a negative charge and is our anion. The other two types of bonds are listed here, but we're not going to go over those because that's not the focus of this unit. So again, as I said, we're going to do ionic bonding. And ionic bonding, our metals are positive. They are a cation. And my nonmetals are negative, so those are my anions. This is where I said in class, here it comes, the way to remember this is because a cation is positive because cats are positive, because they have paws, get it? So we have the paws for the cat. And then we also have, some other people will say, well, it's because there's a plus sign in cat that looks like a positive. So I don't care how you remember it as long as you remember it. And then our nonmetals are our anions. And so what is bonding? Well, bonding is attraction. We've been talking about attraction. There's attraction between atoms, in this case specifically attraction between ions. Another way to explain bonding is it's the potential energy, it's the stored energy. And so the closer atoms are to each other, the lower their potential energy to come even closer. So as our atoms bond, the potential energy decreases. So this means that our chemical energy, the opposite of potential energy, the chemical energy increases as they bond. There's that chemical energy that is stored in the bond. So with that in mind, we're going to come down and we'll discuss our ionic is our metal and our nonmetal. So as we said, the metal forms a positive because electrons are transferred from the metal to the nonmetal. And this forms charged particles that attract. And so in the last unit, we talked about how, well, metals lose electrons and nonmetals gain electrons. We're going to change our terminology and we're going to say that the metals have their attraction to their electrons broken, and the nonmetals form an attraction with the electrons. That's going to help us talk about energy a little bit better. And so then I just gave an example of a Lewis dot. And so with our Lewis dot, I'm showing that our sodium has one valence electron, and we're going to break its attraction with its valence electron. And chlorine has 7 valence electrons, and so it has a high attraction. If you remember, we called this electronegativity. There's a high attraction to the electrons, there's a low attraction to the electrons. And so sodium's electron is going to be attracted to chlorine. That's going to give sodium a +1 charge and chlorine a -1 charge. When they come together to form bonds, the purpose of forming bonds is to form a stable unit. In this case, it would be NaCl. So our compound, our ionic compound, is neutral. It's forming a stable unit. A stable unit is neutral because all of our protons are taken care of and all of our electrons are taken care of. Everything is in its stable, complete valence shell form. Well, when these things form, they form at first, if we have just the simplest form. So our simplest form is going to be where I have my cation. Remember that my cation, since it has more positives than negatives, is going to have a smaller ionic radius. I'm going to say that this is a +1. So then my anion is going to have a larger radius because, again, remember that my anions have more electrons than protons, and so it's going to pull it away from the center. So this is going to be, I'm going to change this. I'm going to make this a -2 in this case. Let's say that I'm doing sodium sulfide. And so, in order for these to balance out, this isn't neutral yet. I have a +1 and a -2. So right now this is a -1 overall charge. So I need 2 sodiums, and that's where I get the 2 there in the sodium. I need 2 sodiums to balance out this charge. Now that my charges balance out, I have a complete neutrally balanced unit. This is referred to as my unit cell. So a unit cell is a single compound of sodium sulfide, or of our ionic compound that we're talking about. Remember we said that bonds are attraction, and so we don't have lines here. I know sometimes when we picture bonds, we picture them being physically connected. That's not the case. It's just the attraction of the electrons to the other atom's nucleus. And so that attraction is what we call a bond. Well, with this, these aren't exactly going to stay as just single unit cells. What happens is that these will bond, they'll mix around, and they will stack. And so when they stack, they'll stack in alternating charges and form a crystal lattice. It doesn't matter what the formula says. Just because this is Na+2, just because I have 2 sodiums does not make it sodium +2. It is still sodium +1. The sodium ion is a +1. That's why I need 2 of them to balance out my sulfur -2. And so because of that, my crystal lattice is always going to form as positive, negative, positive, negative, negative, positive, negative, positive. It's always going to have that alternating pattern. So you will never have 2 anions beside each other. You will never have 2 cations beside each other. And what I'm showing over in this other neater picture is that this should look kind of familiar. It looks almost like our Legos. And so just like Legos have those little nubbins so that they can form a tight attraction, a tight connection. And so that's what it does. And so this becomes far more stable. And remember we talked about it earlier, the reason why ions gain and lose electrons, the reason why they attract and break the attraction of the electrons, is so that they can have a complete shell and be stable, be unreactive. So the more stable something is, the less energy it takes to hold together. And so when we form this crystal lattice, this is a very stable structure. A cube is going to be much more stable than a simple unit cell. So this is much more stable than just this, or than just the ions on their own. And so since it's more stable, stacking multiple unit cells, so our crystal lattice is stacking multiple unit cells. That's what we call this cube. The lattice energy is the energy released when the crystal lattice forms. If we have higher attraction, it means we're going to require less energy needed to hold it together. This means the higher the attraction, the more lattice energy we will have, because the lattice energy is the energy released when that attraction between ionic compounds forms. So energy released when ionic compounds form. And so as we talk about over here, my crystal lattice forms, and so my crystal lattice requires a lot less energy. It's much more stable, so it requires less energy. So since it doesn't need that energy, it releases that energy from the system. And if we remember back to our heat unit, we talked about when energy leaves the system. This is our O. Remember when we did our LOL diagrams? When energy leaves the system, it's exothermic. My energy is negative because it's leaving the system. I'm subtracting energy from the system. And so, when energy is released, a solid will form. This crystal lattice is much more stable, so it's a solid cube. It's going to be a solid. My atoms are coming close together, little space between, very dense, which makes a solid. It's warm because that's the energy being released as heat. Hopefully that helps to explain ionic bonding. So when ions bond, they form an ionic compound, and the structure of the ionic compound is in a crystal lattice because that's the most stable form with the highest amount of attraction and the lowest amount of energy required to hold it together. That energy is released as lattice energy.